Okay, everyone, let's get started. There are only 30 of us, 31 people here, but I'm sure more will trickle in as we go. So I'd just like to begin by asking if you have any questions from yesterday or any organizational kind of questions. Go ahead, if you do. Okay, I assume not. That is fine. I'll always start the lecture asking, if there are any questions. So just some organizational things from my end. The homework is due Friday, okay, 9 p.m. And this afternoon, if you go to our, you should be able to see this because I'm sharing my screen. This afternoon at 1 p.m. Are Patricia's office hours, okay? And what we've done yesterday, we had some issues, some like technical difficulties with Zoom for Christian's office hours. And so what I did is I subscribed, we were all sharing one Zoom account, and I decided, you know what, let's just subscribe everyone to this, to their own, unique Zoom account. So what will happen is you'll get an email from Patricia, maybe 10 or 15 minutes before her office hours. Okay, so around 12:45, look for an email from her, and then join those office hours. The office hours are optional, but I highly recommend. I mean, if you haven't started on the homework, you only have 3 days. Less than 3 days really. Today's kind of gone, and right. So you can. So someone drew on the screen. So yeah, you can. I guess you can draw, which is nice. So if you have questions, we can actually collaborate. Okay, and so please, I would highly recommend. Patricia is wonderful. She'd be happy to help you with homework. Does anyone have any homework questions? I mean, you can ask these homework questions here too. We have some time to discuss these things. The homework is not easy. Okay, so I would recommend getting started. Okay, let's see how many people. Okay, so there are 40 of us. Okay, great. I think let's begin on the actual content. So yesterday we talked about this big equation, and so let me pull up the roster of names so I can start calling on people. Let's see, is Jaden here?
Yes.
No. Let's see, is Monica here? I guess there are less than half the people here, so I have less than half 50% chance of, is Brianna here?
Monica's here.
Oh, Monica's here. Okay, Monica, can you tell us what the X-intercept is of this equation?
Did you say intercept?
Yes, the X-intercept. Do you remember? And can anyone, if you don't know, can someone help her out?
Negative b divided by m.
Negative b divided by m. Yes, and so that was the correct answer on the quiz yesterday. And was it long? You answered that. How did you get that?
I isolated x, and since y equals 0, this yeah.
Yes, exactly. So Long basically said, okay, well, what is the x-intercept? The x-intercept is the point at which y equals 0. So if you set y equals to 0, then you get this equation, and then you can solve this simply for x. We've done this for many years, from middle school, and you subtract b on both sides. So we did this yesterday. This is just a review, okay? And clearly, this is the x-intercept. So you'll hear that this is actually a very significant expression. It looks very simple. It's just a fraction. But you'll hear that this is sometimes called the solution, okay? Or the root, or the 0. And these are all synonymous, okay? When we talk about quadratic functions and cubic functions, which are on the SAT, and you'll definitely encounter them in high school more. Finding the solutions is not this trivial. So for the quadratic, family of functions, you have something called the quadratic formula. That's the analog to this solution here. For the cubic function, you have an even more sophisticated expression for the solutions. And it actually turns out there's a famous theorem in math that says that a quartic function or more does not have an explicit solution. So if you have, so we'll talk a lot about polynomials and what this means, but yes, that's the right answer. So thanks, Monica and Long, for contributing. Can anyone tell me, I won't call on anyone, should be very easy. What is the y-intercept of this equation? Just shout it out. B, very good. B. And what is M?
Slope.
Yes,
Slope.
great. So you've heard that, you know, M, can anyone sort of give me, if I were like a 5th grader and I really had never seen this before and I didn't know what slope is, can someone explain to me sort of intuitively what slope is?
The steepness of a line.
The steepness of the line. Very good. I like this word steepness. Very, very nice. And so can anyone else contribute maybe like a little cute formula? I'm sure you've all, you know, you have your own ways of thinking of slope.
Rise over run.
Rise over run, yes. So, and so that rise over run is precise. What is rise? Rise, you know, going in this direction is a change in a y value, right? So you could call that change in a y value y minus y1, say, where y1 is any point on the line. And what is run? Run is a horizontal change, and you could call that change x minus x1, right? Where x1 is any point on a line. And so what you said, I forgot who said that, but yes, rise over run is precisely this divided by this. And so if you do that, you know, y minus y1 divided by x minus x1, if that's defined to be slope, then if you just multiply both sides by x minus x1, then you get this expression, which is a famous, I'm sure you've all seen this before as well. It's called point slope form. And so where is this useful? This is useful if you're given the slope and you're given any point on the line. So say I have a line and I know, just make it up. Say that the slope is 1/2, and say that the point, that the point 1 minus 2 exists on that line. Then I could immediately tell you that the equation for the line is y minus, look, y1. This is y1 is -2. So minus y1 is +2, right? The slope is m, so it's times 1/2, x minus, this is x1. So this is a valid equation for the line, and it's a fast way to answer questions. So on the SAT, if they ask you, what is one valid equation on a line that describes a line, and they just give you a slope and a point, this is the way to go, okay? This is a very fast, you don't have to calculate the y-intercept, you don't have to do any of this nonsense, right? You don't have to do the x-intercept. This is just very formulaic. And we'll see today that you can go from here to here, and you can, and back and forth, okay? So given this slope-intercept form, you can get the point slope form and vice versa. Make sense? Any questions? So today is going to be a lot of actually doing problems. So yesterday was a very general overview. I was just trying to sort of describe the basics, give the big picture of math. Today, I hope you all have like a pencil and paper because we're going to be drawing graphs and doing all sorts of fun things, okay? Okay, so the parent function. Can anyone tell, let's see, is Rosalva here? No. Is Caleb here? No.
Yes.
Caleb, okay, you're here. Okay, can you tell me what the parent function is?
Y equals X.
Nice. Yes, so for lines, the parent function is y equals x. But it is, so sure. But the parent function is actually more general. When people talk about the parent function, they're usually referring to a whole class of functions. Okay, so the parent function for lines is y equals x. And, the parent function for parabolas, so you're all familiar with this shape graph. The parent function for parabolas is y equals x squared. The parent function for sinusoidal graphs, so eventually you'll come out with, you'll look at graphs that look like this. Okay, 1 second. Let me just finish explaining this and I'll see the chat. The parent function for sine, waves is y equals sine. So the parent function is basically the function that is as simple as it gets. Okay, let's see. Is the simple, yes, Robin, yes, very good. Is the simplest function that still satisfies the definition of a certain type. Very nice, okay. That sounds almost like Wikipedia, but that's great, thanks. So yeah, so it's the simplest. So we often start with studying the parent function because it doesn't have anything out here. It doesn't have like +1 and it doesn't have any coefficients here. Y is not manipulated. But using the parent function, we can develop an understanding of how the function behaves upon these transformations and dilations. And so we're going to do a few examples that should be very straightforward, very trivial to you all. And we're going to do them by making tables. So like X, Y kind of tables. And we're going to list some X values, and then you're going to help me find some Y values. And we're going to do a few graphs like that. But then we're going to ditch this very childish technique of just, this is essentially how a computer will do things. We're going to ditch this very computer-like process, and we're going to instead think of transformations and dilations on the parent function. Okay, so let's just graph this function. It's as simple as it gets. I'm going to give you some X values, and you're going to tell me what the Y values are. And just shout it out. If the X value is -5, what is the Y value for Y equals X?
-5.
Yes. This should not be mind-bending. If the X value is -3.
-3.
Yes. If the X value is -pi.
-5.
Yes, it's the same thing.
Always
Okay,
the
so
same.
-5.
yes, good. It doesn't matter what this value is, right? If it's minus, you might know of Avogadro's number, 6 times 10 to the 23rd. It's given by this. If this is NA, this is Avogadro's number as well. Okay, so you get the point, right? And basically all this, all of you have seen this before, nothing hard. I'll try to draw this to the best of my ability. You just get a nice line. I don't know why I'm getting this message. I have Zoom Pro. Okay. Okay, makes sense. So here are some guidelines regarding graphing, because you have to do some graphing on the homework. Please label your axes. Okay, so X and Y. I will not require that you put arrows like this, because I personally think that's annoying, and no one in the professional world will put arrows on their graph. You can just draw a nice line, okay? But do put some point on the graph that gives you the sense of scale. So don't do this. I see people do this. That's very irritating to look at, right? And you like label it 1, 2, 3. Don't do that. Just put 1 point, because 1 point defines the entire scale of the graph. So this point, you could just write 3, 3, for example. Okay, and that's indeed, you could put that into Y equals X. This is indeed a point on the graph. Make sense? Any questions? Very straightforward. Yeah, I heard someone say something. No. Okay, let's try this. Should be almost as easy. Okay, what if X is -3? What is Y?
-3. Oh, wait,
-2.
Is it -4 or -2?
-2. Sorry.
-2, yes, okay. Now, yeah, just basic addition, right? Okay, what if X is -1?
0.
Yes,
No.
what if X is 1?
2.
Yes, I'm just kind of skipping around. What if X is pi?
Pi plus 1.
Yes. What if X is 1,000?
1,001.
Yes, very good. Okay, so what does this look like? If we were to just use these first few points. Okay, so -3, -2. It would be somewhere out here, right? Further in this direction than this direction. So somewhere here. -1, 0. So hey, I actually guessed. What is this point called? What is this point called?
-1, 0.
Yeah, it is -1, 0, but it has a name.
Y-intercept.
Is it the Y-intercept or is it the X-intercept?
X-intercept.
It's the X-intercept, because it's the place where the graph, where the line crosses the X-axis. Okay, negative, let's see, 1, 2. Okay, so 1, 2. So somewhere up here. So look, I didn't guess in this entire thing, I didn't guess the y-intercept. But what do we know the y-intercept to be? It's in the equation. Look.
1.
Yes, it's 1. Good. So I could just put that on. And I know that the y-intercept is 0, 1. And so clearly we have this nice line, okay? And it goes on forever. Make sense?
Yeah.
Okay, good. So let's do a few more. So what do you notice? How would you compare this graph, what we just drew, to this graph? Can you see them both? How do they compare?
Oh, they're both
have-
a straight. They're both a straight line.
They're both, okay, good. They're both straight. Well, so all lines drawn in Cartesian coordinates, like in X, Y coordinates, are straight. All lines are straight. So that's a good place to start, but let's do a few more examples of this nature, and then let's look for similarities, okay? Because it'll be obvious when we have a few examples. Okay, let's do this. X is -3. I'll use the same points. What is Y?
-13.
Yay. What if X is 0?
-10.
Yes. Thanks for participating. I want a resounding chorus because this is actually, I could ask these questions to like first graders, right? Well, maybe not minus num, maybe not negative num, but let's all participate. Okay, what is Y when X is 3?
13.
Negative.
-7.
-7.
-7.
Make sense? Yes. What if X is 10?
0.
Yeah. And so
Zero.
and looking at this graph, what is, well, actually we have nicely both points. What is this point called?
Y-intercept.
The
Which-
y-intercept.
Yeah, the Y-intercept.
Is it the Y-intercept?
Sorry, X-intercept.
Okay. Maybe we should, okay. First, what is this point called? What is the point when Y equals 0?
That's the
Y-intercept.
X-intercept.
So look at the graph. It's kind of hard to visualize sometimes.
Slope.
This is the y-axis. This is the x-axis. When y equals 0, this is the x-intercept, right? Because this is the point at which the graph intersects the x-axis. Yes?
Yes.
Yes. And this is by elimination the y-intercept because look, x is 0, then everything is confined to this line. Okay, so now let's draw this. -3, I'll go faster with this. -3, 13. It's something way down here. 0 minus 10 around here. 3, 7 somewhere around here, and then 10, 0 somewhere out here. Make sense?
Yeah.
Okay, let's do one last example of this nature. Okay, what if X is 3? What is Y?
3 minus pi.
Yes, very good. And now you all are high schoolers, so we're not going to call pi 3.14. We're going to call pi pi, okay? So this is exactly how you would write it. There's no better way to write this, okay? What if X is pi?
Pi.
0.
Yes. Yes, what if X is 2 pi?
Pi.
1 pi.
Pi.
Pi. Very good. So this actually is very interesting because I had a great teacher in high school who asked me, this is a little detour, okay? Say I have the number line, okay? And I have the numbers, 1, 2, 3, 4, 5. And she asked us, I want you to exactly put a dot on this graph where pi is. So if this is the x-axis, plot this point on this graph. Can anyone suggest how I would do it? Is it even possible?
No.
Why?
Like
It's
3.14.
irrational.
If it's exactly, you can't do it exactly. You'll probably be off of it.
You would probably, yes. So I could get a magnifying glass and I could look at this very, look, in fact, this zooms in. See, I could go further and further in and I could get even more precise. But no matter where I put that point, given these axes, there will still be some error. And let's see, someone has messaged. It's an irrational number. That's exactly, yes, thank you. So pi is an irrational number. So it's impossible to plot an irrational number on a rational line. Let's see. Cannot be defined by a fraction. Very good. Yes. So that's exactly the reason. And so the follow-up question is there a way to plot pi on any line? Can anyone think of
There is a way. Like if the scale is like 3 point, like say pi is one of the scales, like it's goes out pi, 2 pi, 3 pi. then
Exactly.
you can plot it.
Very good, Adi. Thanks. And that's exactly the reason. So Adi very cleverly suggested that maybe let's just define this in the following way. Multiples of pi, right? So then pi is exactly at this point. There's nothing wrong with these are still equal spaced intervals, just as we had -1, 0, 1, 2. I've just basically stretched this axis, this old axis that we had spaced by the number 1. I've stretched it by a factor of pi, right? Times pi. I've multiplied the entire. So it's like taking a rubber band and just stretching it the right amount. Okay, and now I can plot pi exactly. So does that make sense?
Yeah.
Great.
Yeah.
So that's sort of what might be valuable here, because look at this pi. We have some notion of pi, and if we want to plot it exactly, we're going to have to define at least our y-axis in terms of pi. Because look, this is our y-intercept. So look, minus pi. I'm just going to put it there. That means that this is pi, and so on and so forth. So this is a point on the graph because look, I didn't put it in, but when x is 0, then y is -pi. This is the y-intercept. Okay, so this is a point. And then pi comma 0 is also a point right here. Okay, and now we have 2 points. This is really all we need. And we can just draw a line through these things. Does this make sense? Would you all be able to do this? Defining your axes in terms of an irrational number?
Yeah.
Yeah.
Great. And it can be any irrational number. What are other irrational numbers you people know?
E.
E.
This is one.
So if it were x minus e, it would be the same graph, just all these numbers are e now. How about square root of 2? How about square root of 3? Any of these numbers, are irrational. You can't.
Would imaginary count?
Imaginary numbers are totally
No,
that's a
'cause
whole
it's
thing.
not.
And we're actually going to spend a full few weeks, not a few weeks, but a few lectures on imaginary numbers. So no, imaginary
It
numbers.
has to be real to be irrational, right?
Yes. So we're going to talk about the classification of numbers. It's a big tree, actually. It's really beautiful. Let's save that discussion for then. But you can't plot complex numbers on the real plane. Okay. But complex numbers can have
Thank you.
Yeah, sure. We'll talk more about that. So my question: what do we notice about all the above graphs? So I'm going to zoom out, and hopefully you can see. And hopefully I drew things. Go ahead.
They're all linear.
They're all linear. I think someone said that after just the first 2. Can you be more specific? And maybe I didn't draw them perfectly, but look, which direction do they all point?
They all have the same slope.
They all have the same slope. Yes. Who said that?
Me.
Okay. How do you
Ria.
pronounce your name? Ria? Okay, great. Thanks, Ria. That is the insight that I wanted. And if things all have the same slope, if I were to draw them, maybe if I drew them closer, like look, these lines all have the same slope. What is true about all these lines?
They're parallel.
They're parallel. So we have this observational insight that lines with the same slope are parallel. Okay, very profound. And the only way these things are different is what? This number here, right? What is this number called?
Y-intercept.
Yeah,
Y-intercept.
so clearly, look, for y equals x, this is the parent function. It goes right through the origin, right? You see this? It goes right through the origin. Now, when I added 1, it just shifted the entire graph up by 1. Look, it's the same line. So if I plot them both on, so if this is y equals x, then y equals x plus 1 is the same line, just shifted up. This is not a good drawing because I'm not good at drawing this, but these are parallel lines. It's the same line. And similarly, y equals x minus 10, it's just y equals x moved down 10 units. Point. 0, comma, minus 10. It's the same line as, what we're used to, the parent function, just moved. So this is the power of thinking about things. Instead of drawing these stupid tables, just think of things in terms of, manipulations of the parent function. So if I gave you, we'll have plenty of examples, but if I gave you y is x plus 1,000,000, okay, would you make a big table and compute all these numbers?
No.
No. And you would instead just draw this, and you would say, this is just the point 1,000,000, 0, 1,000,000, right? Make sense?
Yeah.
Yeah.
Okay, great. So this is one of the major themes of this course, being able to draw graphs without making tables. It's very powerful. It'll save you lots of time, and it's an essential skill for college and high school and college and beyond, okay? Looking at a graph and having intuition. Okay, so far in y equals mx plus b, we've only looked at manipulating and varying this parameter, this y-intercept, essentially the height of the graph. Now let's talk about manipulating the slope. And for this discussion, we'll keep the y-intercept as 0. Okay, for simplicity. And then we'll put everything together and be able to draw graphs in general. So, okay, I'm going to put in some points here, okay? You're going to help me. Okay, let's just work with these. What is the y value when x is -3? Everyone, together. -6, good. What is the y value? What is this one?
-4.
-4. What is this one?
Negative.
Yes, very good. And you can see, you don't even have to compute things. You can see the pattern because it's a linear graph. Clearly, we're adding 2 each time, and you don't even have to think about it. As long as these are equally spaced, which they are, this is clearly 0, and that's clearly 2. So what does this graph look like? If I were to plot it, I would have, -3, 6, -2, 4, -1, 2. This is not very well done. You get the point, right? And it would go on like this. Okay, so sorry about the bad graph, but
Linear.
sorry. Okay, does this make sense? Okay, let's do another example so we get the point. This should be very trivial. Okay, -3, what is y?
3.
-2, what is y?
2.
2.
-1, what is y?
1.
Yes. Pi, what is y?
-5.
Very good. Yeah, so it just takes everything and it just flips the sign, right? It takes all the x values and just flips the sign. So this, intuitively, we should know that there should be some reflection involved here. So I'll draw the graph according to the points that we've decided, and then let's make sense of it. So -3, 3, -2, 2, -1, 1, minus pi, it's a bit more than 3. So sorry, pi minus, this is plus pi, so that's on this side, and it should be around here. Okay, this is the line. How does this compare to the parent function?
Yeah, I got a vertical stretch to it.
Is it a vertical stretch? Was it stretched?
Oh, sorry. Vertical reflection.
Reflection, yes. Yeah, so and where is the axis of reflection?
Y-axis.
The y-axis, very good, this axis. So everything just got reflected. It's like a mirror, basically, right? So clearly a minus sign, when you invert the slope, when you make it a minus sign, everything gets reflected from what it would have been without the minus sign. So if I had, look, on this example, if I put a minus sign here, this is the exact same graph, just reflected. I don't have to compute any points. I don't have to do any of that stuff, okay? Make sense? So when you see minus sign, boom, done. Okay?
Okay.
Great. Let's do this. What is, okay, I'll pick even numbers to make the math nice. Can you tell me what the y value is?
-2.
2.
Yes, 2. Does it make sense to, I mean, we shouldn't have disagreement about this, but we all make mistakes, okay? What is this value?
1.
1. What is this value?
0.
0.
So on and so forth. not going to waste time on this. -4, 2, -2. Sorry, -4. I drew this wrong. Look. Let me erase. -4, 2, it's above the axis. -2, 1, 0, so on and so forth. You know, all you really need to graph a line is 2 points. And this is what Euclid said, right? Given any 2 points, you can form a unique line. And so really, I don't even need more than 2 points here, but I'm just kind of giving you the general shape, okay? Great. So is this steeper or shallower than like what we would think of as the parent function?
Steeper.
Shallower.
Shallower.
Okay, so which one is it?
Shallower.
Whoever said steeper, can you tell me why? Or did, okay, whoever said that must have changed his mind. It's shallower because look, if, this is kind of misleading because of this minus sign, but if I were to compare it to y as minus x, which is the analog, look, this is y equals minus, this is y equals minus 1/2 x. This line is steeper than this line. So generally when this number is less than 1, specifically when the absolute value, okay, this is kind of more technical, but when the absolute value of the slope doesn't, because it's absolute value, we don't even need to bound it. When the absolute value is less than 1, your line will be shallower than the parent function, y equals x, or y equals minus x. Make sense? When it's more than 1, the opposite case is true and it's steeper. Okay? So far, so good, everyone? Any questions so far? We're just running examples and looking for patterns. Okay, let's try this. Last example, then we'll do some practice problems. What is x? What is y when x is -1?
Pi.
What is y when x is -2?
2 pi.
What is, okay, you get the point, right?
Yeah.
And so what does this line look like? If I were to draw this is the last time I'm doing this with a table. Okay, this is the last time you'll ever see me do this. -1 pi, -2, 2 pi. Here are my 2 points. Clearly the point 0, 0 is on the line, right? It looks like this. Is this steeper or shallower than the parent function?
Steeper.
Steeper, and why? Because the absolute value of -pi is greater than 1. This is like 3.14, blah, 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 you know? And the absolute value is 3.14, which is clearly greater than 1. Make sense, everyone? Okay,
Yeah.
great. Now is your turn. So get your pencil, get your paper, and let's do these together. So I'll give you like 30 seconds to draw this line, okay? And then we'll talk. Starting now, go. Okay, time's up. Now, I think you all have some ability to annotate on my screen. In fact, I saw someone draw earlier. Can anyone be bold enough to try drawing on the screen? Hey, good.
So that's the line.
Nice. Okay, good. So does it match our intuition? Is it, first of all, if I were interested, so first of all, do people agree? Is this roughly what people got?
Yes.
Yes. Okay, so if you were interested in seeing whether these points actually fit the graph, well, this one is very good, and I'm glad you picked this because it's clearly the Y-intercept, right? This point we'd actually probably have to put in, and you wrote 5 plus 3. Is this a 5?
That's a 0.
It's a 0. This is a 0?
Yeah, sorry.
Would it make sense for such a point to exist? Like, so you're saying that this point is this?
Yeah.
Well, then why is it? This
I'm
is
sorry. No, that's a 5. That's a 5.
It's a 5. Okay. So if it's a 5, and this is what? Is this 13 or 3?
That's 13.
13. Okay, great. So then your answer is indeed correct, because if you put in 5
Yeah.
times 5 plus 3 is indeed 13. Yes? Everyone agree? So if you're drawing tables, stop. Don't draw tables. How would I have done this problem? I would immediately put this point, right? I would immediately say, okay, this is the y-intercept because it's given right here. I would probably also include the x-intercept. And on the homework, I think I've asked you to do this. And we know that the x-intercept is what? Minus b over m. What is minus b?
The slope. The y-intercept over the slope.
Yes, and so what is minus b? Minus 3. And what is m? 2.
2.
And so my
2.
x-intercept, in other words, this point, is minus 3/2, 0. And so I would have, that's the way I would have done this. I wouldn't have, done any table business, and it would have been very straightforward. This is the right shape. Good job. Okay, next. Oh, kidding me. Okay, so we're stuck with, okay, I guess I can erase clear all. Okay, great. Okay, next one. How about, I'm not even going to give you time to do this because you don't need time. And this is, you should all kind of have this under your belt. Can anyone be brave and draw what they think? Good. I think this is the same person, maybe?
Yes.
Is that your final answer?
Yeah.
Okay, who agrees?
I don't understand the numbers.
You don't understand the numbers. So I think this is a 1, 3.
Okay.
But is that
How's it with 1?
so does that fit the graph?
Is paying for SAT.
Does that fit the equation? So in other words, if you put in 1 for x, do you get 3 for y? 10 times 1 minus 7. Does that equal 3? It does equal 3. So that point is correct. But does the y-intercept match? What is this? What is this? Is this above the x-axis?
Oh, sorry. I just put it randomly. That was supposed to be -7. It was supposed to be below.
Okay. So your entire line needs to be
Shifted below.
here, and this point needs to be negative, kind of 0, -7, and then your 1, 3 will be. This is not a good. Yeah, I didn't draw this very well. In fact, here, let's just, I'll do this the right way and. Okay, so give me a sec. Oh, okay. Let's see. We are all. So this is. Okay, sorry. Okay, I'll just redo the. So first of all, do we know anything about the steepness of this line? Is it relatively steep or shallow compared to the parent function?
Steep.
Steep, because, yes, and that's because this is a big number, right? The absolute value of m is not much bigger than 1, but it's bigger than 1, and it should be pretty steep. So we know that the line, it's going to have like this kind of slope, right? Pretty steep. Now we just have to figure out where to place it, basically. And this point, 0 minus 7, it gives us it gives us what we want. And what is the x-intercept? Minus b over m, which is what? Minus
3 over 2.
3 over 2? How'd you get that? I think you're thinking of this. It's just 7/10. Okay. Does everyone see? This should be very easy. You just put in b, you put in m, and this is the number you get. And then this is your line. Okay, so pretty steep. Make sense?
Yes.
And if you want to include the point that Adi put, I think it was like what?
1.3.
Yeah, it's just about here. Okay, good. Okay, now I want someone else besides Adi, but thanks for participating, Adi. Now, someone else. Don't be shy, please. Okay, thank you, thank you. So that's nice, that's your Y-intercept. 0, 6, very good. And I don't know, are you still going? Okay, good, I see another point. So you put in -3 into the equation, and you're finding that the Y value is? It's taking some time. What happens if you put in, I don't know if it's just a delay, but what is this? 9 plus 6, so 15, right?
Sorry, it's really hard to draw on the thing.
What is that?
Sorry, it's really like when you draw on it, it doesn't go like where you push on it.
Oh, I see.
Like
Okay.
I'm using my phone.
No worries. Okay. Well, thanks for you got the gist. Okay. Does everyone agree that these points are on the line?
Yeah.
Good. What is the Y? What is the X-intercept? In other words, where does it cross here?
-2.
-2. And yes, indeed, if you put in actually, be careful. It's not -2.
Sorry, 2.
It's 2, right? Because you have minus and then minus b. Sorry, this minus sign should be 6 over -3, which is 6/3, which is 2. So the point 2, 0 is on the graph. And indeed, your line is nice. And it matches, is it steeper or shallower than the parent function?
It's
One
steeper.
is steeper.
It's steeper because why? Because this number is greater than 1. Great. Okay, now slight detour. Because now, okay, I'll clear the screen again. Okay, now we're going to start talking about things in this form. And to go from this form, what is this form called?
Point slope.
Yes, and to go from point slope form to slope intercept form, we need to use the distributive property, and surely you all have seen this before. Okay, can someone tell me, please tell me what this is?
Distributive property.
What is the right-hand side here?
Oh, AV plus AC.
Yes, very good. So this is the very definition. Okay, yeah, feel free to write on the board. I mean, thanks for participating. Yes, good. This is the definition of the, so can anyone actually tell me what this is? You don't have to write, just tell me.
XY squared plus XZ cubed.
Okay, so I heard someone say X plus Y squared.
Just XY squared plus
Yeah.
XZ cubed.
Right, so the relationship between these terms is multiplicative. The relationship between these terms is additive. So similarly, this is equal to X times Y squared plus, look, I'm just following the same template, X times Z cubed. Make sense?
Yeah.
So this is so on your homework, you're gonna have like 10 problems of the distributive property, and some of them get pretty hairy, okay? So it's gonna really test, do you understand what's going on? Now the opposite of distributing is factoring, okay? And so in other words, if I were to go from here and I wanted something like this, so going from the right-hand side here to the left-hand side would be factoring. Going this way is distributing. And so if I wanted to factor this thing, I would look for the common terms. And what are the common terms?
X and Y.
There's, yes, both of these terms shares, sorry, not the common terms, the common factors.
Oh.
Yes, so both of these terms shares the factor A, and so we can take it out, right? And multiply the entire thing by what's remaining. So you all should be familiar with this from middle school, right? Okay, so let's factor the following. What is common among these terms?
X
and
and Y.
Y.
X and Y. Does everyone agree?
Yeah.
Okay. I'm only hearing like there are 45 of us, so please, everyone, let's all participate. Okay, so X, Y, and what would be remaining? Someone I haven't heard from today.
Oh,
Let's see. Julia, could you tell me what's remaining?
X plus Y.
Yes, very good. Very, very good. So indeed, if you were to, I trust that everyone knows how to do this, but indeed, if you wanted to check Julia's answer, which is correct, you could just multiply this out and you get X times X, Y, using the distributive property, and plus X times Y. And what is X times X? That's just X squared. And what is Y times Y? That's just Y squared. So this is indeed the correct answer. Very good. Thank you. Now let's look at this one. What is common between these two?
A, B, and C.
A, B, C.
And all to first order. So how would so if I took A, B, and C out, what would be remaining?
D.
Yes, and in fact, someone has chatted. Okay, and someone nicely, I don't know if you people can you see this chat if I open it here?
Yeah.
Okay, you can see this. Okay, nice. So this is very good. Someone has, I meant D instead of S. Yes. And I think you're missing, so does everyone agree with this answer? Is this the same thing as this? Can you all see this? So
Yeah.
I'll write it here so you can, it's nice and big. A, B, C. This is what Alexis thinks. Is this the same thing as this?
No.
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 Oh, it's
What did you
not.
miss?
You have to do +1.
Yeah.
First of all, there are some issues with the first term.
It should be d to the power of 5.
Yeah, it should be d to the power of 5 because d is not common between these two terms. So yes, that is to the power of 5. And what else is missing?
+1.
The plus.
Yes, the +1, and it's okay. Thanks for participating. And yeah, I think the chat is a good way to participate. I can read that easily. So, okay, does it make sense? So you'll have much more practice on the homework, okay? So let's apply our distributive property to this. So first of all, let's do this the easy way, which would be just taking the point given. So remember, point slope form. We're going to take the point x1, y1, and we're going to use the slope, and we're going to construct our graph that way. And then I want to do it another way, which would be converting this to slope-intercept form. So the first way, what is x1, y1? Can someone tell me using this equation?
-1, 1.
Okay, so be careful because look at this equation. It's y minus y1 is m times x minus x1. You see these minus signs?
+1.
Yes. So who was that who suggested that?
-1.
Okay, you all have to speak clearly because I can't really hear you.
1, -1.
Is it 1, -1?
Other way around.
Oh, other way around.
-1, 1.
-1, 1. Okay, so let's see. -1, 1. Does it make sense to everyone why? Because look, because of this minus sign, you could actually write this as x minus -1, right? To match this form. This is the same thing as x plus 1. And clearly your x1 then is -1. And similarly, you could write this as y minus -1 to match this form of y minus y1, right? We want this minus sign to be able to compare these forms. And clearly y minus +1 here. y minus plus 1 is y minus 1, right? So indeed, your y value is 1. Okay, so this lies where on the graph? Let's see, minus 1, 1, somewhere here. And the slope is 2. So, using our old school understanding of slope, we know that slope is rise over run. So if this is minus 1, 1, I could go up 2 and right 1, up 2, right 1, so on and so forth. So if I go up 2, this would be, the y value would be 3 because I've added 2 here. And the x value would be 0 actually, right? So I'm going right 1. And then the next point would be right 1, so 1 and up 2, 5, right? So this is our line. So this was using point slope form. Now let's convert this form to slope intercept form and see if we got the same value. Okay, notice that we miraculously got, just by coincidence, we got the y-intercept just by, the way the numbers worked out here. It was a convenient point. But let's convert, how would I write this in slope-intercept form? This is a very crucial skill. What's the first step?
Distribute.
Distribute. So I'm going to distribute. What's the right-hand side become?
2x plus 2.
Yes, good. Now how do I proceed?
Add 1 to both sides.
Add 1 to both sides. And what do I get?
3.
3, good. So this is our slope-intercept form of this graph. And indeed, the y-intercept matches, and the slope is obviously preserved to be 2. So this is indeed the same line, right? You could put in, let's just test. Put in the point 1, 5. Does 1, 5 satisfy this equation? In other words, is our old graph correct? Does 5 equal 2 times 1 plus 3?
Yeah.
Yes. So there's consistency between these two equations, and our old graph matches our new graph.
So basically, it's just all you're doing is just converting the point slope back into slope intercept and then drawing it.
That's exactly right. Yeah.
Okay.
Okay. Last example, or maybe almost the last example of the day. In fact, we can make this the last one because there's a quiz and I want you to have time for that. Okay. How would I do this in point slope form? So what is the point? What is the point x1, y1? So I'll write the equation. Y minus y1 is m times x minus x1. What is this?
X1 is negative pi and y1 is pi.
Okay, so we're making the same mistake. Be very careful, right? Because look, you're forgetting the minus.
Yeah. So it's just pi and then negative pi.
Yes. Okay, so I don't want people to make this mistake, because this is exactly what the SAT people will prey on. Okay, they'll prey on you they will really mess you up. Okay, if you don't have these things clear, right? So be very careful. They'll give you multiple choice questions, and it's like they're throwing sand in your eyes. That's what it feels like taking that test sometimes. Okay, does this make sense to everyone? Why this is plus pi and this is minus pi? Because if I were to match the forms, right, I would have x minus, look, this number is plus pi, right? I'm trying to match the form given by the point slope. And similarly, I could write this as y minus pi. This is indeed the same thing as y plus pi. And y1 is clearly minus pi. So x1, y1 is pi, comma, minus pi. So where is that point? Pi is somewhere here, minus pi is somewhere here. So here. Okay, and what is the slope? The slope itself is pi. So I could go up pi and right 1, right? Rise over run. So does this make sense? Pi, when the slope is pi, then the rise over run is pi over 1. This is kind of a subtle point. Does everyone understand this?
Yeah.
Okay. Let's see. Someone has sent a chat message. Yes. Okay. Good. Thanks, Alexis. Let me know if anything doesn't make sense. So up 1 puts me right on the axis. Right 1. So I shouldn't have drawn a dot here because it's not on the line. And so this is the point pi plus 1, comma 0. And then similarly, I'd have pi plus 2. Yeah, pi plus 2 pi, right? And pi plus 3, 2 pi, so on and so forth. I'm just doing the same rise over run stuff that you people have done forever, okay? And so there's the line. Now, in this method, we didn't get the y-intercept, right? We didn't find this point, and I want this point. We got the x-intercept, that's nice, but I want the y-intercept. So let's convert this to point slope form. Sorry, to slope-intercept form. How would I do that? How would I do that? Distribute, same exact step as last time. Y plus pi. So what happens when I distribute?
So it'll become pi x,
Pi x.
and then minus pi squared.
Very good, minus pi squared. So this is
And
actually a very
subtract
interesting example. Now what do I do to get truly
Subtract pi.
Subtract by
Subtract pi.
pi?
Pi on both sides here.
Uh-huh. So what is my y-intercept?
Minus
Pi
squared
y.
minus pi.
Yeah, minus pi.
Okay, that was a jumble. Please, someone give me a definitive answer. What is the
minus pi squared minus pi.
Very good. So this ugly number, minus pi squared minus pi, is your y-intercept, which is very hard to believe. Because even though we've defined our axis in terms of pi, look, our vertical axis here is multiples of pi. See, pi, 2 pi, 0, minus pi. This number, when you square an irrational number, you're taking it off of the linear irrational number scale. So this number actually can't be plotted. It's kind of an enigma to me that a number so simple from a linear equation, even if the axes are defined nicely, you can't actually plot this. But you can call it close to minus pi squared minus pi. So that's the y-intercept. Make sense, everyone?
Mm-hmm.
Okay, we're gonna forego this last question because it's actually easier than the question we just did. Okay, thanks, Robin. It makes sense. Okay, time for the quiz, and then you people can go. Everyone did pretty well on the quiz yesterday. I think most people got full points.
Everyone got 4 out of 5s.
Right. I discounted that first question. And so on the quiz today, which I just sent out to the chat, on the quiz today, it should give you a true score. So your name will not be graded. And there's also some feedback. So please give me some feedback on the lecture. The quiz yesterday was pretty good. I mean, everyone did pretty well. There were some people who were confused, but I think they got their doubts cleared. Okay, so as you do this quiz, let me plead to you to attend the office hours, okay, at 1 p.m. today. Even if you don't have a question, okay, please make it. Patricia is in charge of them today. She's a wonderful person. She would love to even just talk to you, just to say hello. Just you can introduce yourself. You're going to be working with us for 2 months. So it's good to get to know these people. And I would actually take your homework and just do it in the office hours. And that way, if you have a question, you can just ask. You don't have to wait. You don't have to email. It's the best time, okay? So the office hours are 1 p.m. and you'll get an email invite to join them.
Do we get grades for these quizzes?
You do get grades for these quizzes. You have to have a B- to pass this class, right? Because, and that is mainly determined by your homework, okay? But there's an additional scholarship that depends on your attendance and your attendance grade. So the quizzes are graded, and I
just got a 0 out of 0.
You got a 0 out of 0. Great. Let me see what's going on.
Oh, I think you forgot to add the points.
I forgot to add the points. Okay, well that's.
It says all the answers are worth
What's the
0.
scholarship for though?
Tries to charm.
So it's all written in the letter to the parents. I think I showed it to everyone yesterday. See, how does this hide floating? Okay, let's see. I'll fix the point thing because you mentioned. Okay, here let me pause the. So are you all taking the quiz right now?
Yeah.
Okay.
Yeah.
Yeah, you're right. I forgot to.
Yeah.
Okay. If you haven't.
What's
Yes, go ahead.
what's the code for the office hours?
So you'll get an email. So thanks for asking. You'll get an email from Patricia, who's running the office hours, and there should be no code actually. You should just be able to click on the link and join. We had some issues, and I'm sorry that some people tried to come yesterday to the office hours and couldn't get in because our Zoom was not working for us for some reason, and so. Okay, so
the points are there.
Sorry?
The points are there now. I took it again, and I got 3 out of 3.
Okay, great. I'll discount your first score. Okay, someone has asked, I can't attend office hours today. Okay, is it mandatory? Office hours is not mandatory, but it's highly encouraged. I think, so the homework, I'm here. For those of you who are still here, I'll just open the homework. The homework is, okay, can you see this if I go to my desktop? No.
No, you're still on your whiteboard.
Let's see.
You're gonna have to restart your screen share,
right.
I think.
I think, okay, can you see this?
Yes.
Okay, you can see like the background here.
Yes.
Okay.
Yeah.
The homework is not, you have to make a B-, and some of these questions, I have a feeling many people will miss, okay, which is okay because you can do corrections, but you might need help, okay, and I've given you some hints here.
How do you edit the homework? Because I can't figure out how to edit it.
Do it on a separate piece of paper.
Yeah,
that's
what I would recommend. Yeah, so thanks for asking. PDFs, they're great for distributing things, but I personally have not found a good way to like handwrite on PDFs. And so what I've done is, it would be ideal if you could print it out and just, and then handwrite on it, and then maybe take a picture. Use the camera.
Can you put digital text on there?
You
can download it and then like annotate it, but like that's not really like significant.
Where can we access the homework?
Where can you access the homework? Okay, I'll share the link again. Thanks for asking. So does everyone have this website?
Yeah. It's
okay. So
No.
You don't have this website. Okay, let me
No.
send it in the chat and then save it to your. Zoom, Zoom is great, but it's a bit. Okay, this is the general course website. I just sent that to Ria and not everyone. Okay, so I just sent the general course website to everyone. And this has the office hours schedule if you scroll down and all that, okay?
In email?
Email.
on the chat. In the chat, he just.
It's on the. So if you go to the chat in Zoom, you'll see this. And then you just go to.
It's on the website, but I can't click on it, and it'll like take me there, or is it just there?
Say that you can't click on it?
No, it's
You can't
just
click on-
plain. Yeah.
You can't click on the link that I sent you.
No, it's plain black. It's not like the little blue tab that
Okay.
you click on and it takes you right away. No, it's black.
Can you copy and paste? Can you just select that link that I sent and copy it and paste it?
Yes, you can copy it.
Try that. I don't know why. It's showing as a link on my end when I sent it.
My end too.
Same here.
Okay.
Okay, yeah, it worked.
You got it. Okay, so
Okay.
so now you go to the second tab called Homework and Syllabus, and
Uh-huh.
you'll see the homework right here. Homework 1, due June 5th. That's this Friday.
Oh, okay.
So if you haven't started, I would highly recommend going to the office hours and just start it then, okay? And if you don't know what's going on, these people are here to help, okay? And office hours are every day of the week at different times to accommodate to the most of you. Don't delay, okay, on doing the homework. Like, don't start it on Thursday night or don't start it on Friday morning. You're not going to get through it. Okay, it's pretty long. It's like 7 pages. Okay, is everyone happy?
Yes.
Did everyone enjoy? I mean, even to some extent.
Yes.
Okay, thank you. Good.
Yes.
Yes.
Okay, thanks. That's good to hear. Yes. Okay, thanks, Monty. Okay, great. Okay, I'll see you all tomorrow. And tomorrow you also have your verbal lecture, so that's at 9. And thanks for sticking around these extra few minutes. Let's adjourn. Go.
Sorry to disturb. I'm in like Florida, so is this Eastern time or?
This is Central Time. Yeah, most of us are in Dallas.
Okay.
So yeah, so this is going to be a bit early for you, unfortunately. You're going to be I think we talked actually this morning. Arushi?
Aruhi, yes.
Okay, Aruhi. Okay. If you want to join the reading lecture, I can. Yeah, I'll get you in touch with the right person. But yeah, it'll be the math lecture for you will be at 9.
Okay.
For everyone else, it's 10. Mm-hmm.
Where do we get the reading lecture?
Where do you get the reading lecture?
Yes.
So
It should have been an email.
Emails from Pratik.
Uh-huh.
Let me. Have you been receiving those emails at all, or?
Yes, I have, but I'm not sure how to really do them. I don't know if I should do them on a piece of paper. But I think I'm doing the reading lecture. I think I already started yesterday on a piece of paper, so I think I can finish it that way.
Do you mean the homework or the lecture?
The whole lecture is about like 24 questions, I think they were.
Okay, I honestly don't know what his format for that class is. They're pretty like independent what we're doing. So email him. I really don't know how I can help. It sounds like what you're doing is fine. I mean,
sounds pretty normal, probably, just to do it on a piece of paper. But yeah, okay, I thought you knew, but I guess not. I think I'll ask him up by email.
Ask him by email or tomorrow in his lecture. Yeah.
In his lecture, okay.
How do we join his lecture?
Who is this speaking?
Aruhi.
Okay, Aruhi, I'll send you the details.
Okay, thank you.
Yeah, because you're an exception. You know, you joined later, so.
Yeah.
Everyone else has been added already, but we'll get you in. Okay, is everyone good? Any more questions? Anything you can ask about? I mean, you're free to leave, but if you have questions, let me know. If there's anything, I can stick around for a few more minutes.
You said we had to make a B- to pass.
Yes.
Right?
Yes.
Does that include homework and quizzes or only quizzes?
Right now it's the grade is determined by the homework, but if you don't attend the lecture, you're not going to pass. Like we're gonna factor that in kind of ad hoc. We're not going to calculate it, but I'm looking at your grades. I'm seeing who's doing well on the quizzes, who's paying attention. If people are consistently, it's more like feedback for me. If people are consistently underperforming or are just not showing up to the lecture, then we're not going to pass those students. But I think everyone so far is doing great. So if you're here, if you're attending, you're doing great.
What if you're here the whole time, like you come every day, but you don't say anything?
There's nothing I can do about that. I mean, I wish you all would participate more, but I understand. I mean, it's a huge lecture. Not everyone can participate, but don't be shy. There will be many more opportunities to participate. Okay. But yeah.
Okay.
Yeah.
Okay, thank you.
Sure. Any other questions? If not, I think we'll say goodbye.
Yes, sir. Thank you. Have a nice day.
Okay, thank you. Have a good day. Someone has asked, how do you join the office hours today? Okay, one sec, Selena. Let me just. Okay, so Brianna, is it Brianna or Brianna?
It's Brianna.
Brianna. Okay, I have a friend named Brianna, so that's familiar to me. How do you join the office hours today at 1? Is there a link? Okay, so Patricia, who is leading the office hours, you'll get an email from her, and around like 12:30, 12:45. Okay, and you'll click on the link, and you'll be there. It'll be via Zoom. And does that make sense? Patricia is great. I mean, she'll take care of you guys. Good?
Thank you.
Sure, you're welcome. Selena, is it okay to turn in homework on striped paper? That's fine, as long as it's legible, you know, as long as you can, as long as we can read what you're writing. Yeah. Any other questions? Sure, you're welcome. Okay, there are only 5 of us left. Okay, I'm gonna close the meeting. See you all tomorrow. Okay, bye.